A simple guide to the nervous system. Do you want to know what your brain looks like? How clever are chimpanzees? And why does your knee jerk when you hit it? Well, stay with me and find out. Doing functions of the nervous system. It's about communication. Oh, hold on, sorry. Hello, yeah, I'm just recording a video about the nervous system. So what's just happened? I've heard a noise and that has gone to my brain to tell me what's happening, and then it sent a message down to my muscles to pick the phone up. Now I'm speaking. Great communication system, it works really well. Okay, see you later, bye. So we can really receive stimuli from inside and outside the body. Receiving it from outside the body are things like sound, temperature, light. Got a bit of light going on now, might be squinting. Temperature, what is it at the moment? 3 degrees. So I've got a bit of goose pimples as well. So I'm responding to this external stimuli and I'm trying to create what's called homeostasis. I'm trying to balance the body so that everything remains at a constant. If I'm hungry, what do? I eat. Big fan of that as well. I've got some cake over there I can smell. So smell goes up to my brain, tells me and processes that, and possibly makes my stomach rumble. So all these things are going on all the time without us thinking about it. Homeostasis is working really closely with the endocrine system to balance the body. There are different types of neurons in the body, and neurons make up nerves. I use the acronym SIM, sensory neuron, interneuron and motor neuron. Now what's the difference between the three? Well, hot cup of tea. What have I just done? So I've touched something and the sensory neurons within my fingertips have detected heat, and it's quite hot. I should have gone a little bit cooler with the kettle. So from there, it sent that message up through my sensory neurons, up to my spinal cord, up to my brain, and pass it through a little interneuron, which is only found in the central nervous system. That then passes the message through a motor nerve. So the motor nerve for me would possibly be my bicep or my wrist flexors or extensors, to make sure I let go of the hot substance. So sensory, interneuron and motor neuron are the three types of neurons that we find in the body. Here we have a picture of a neuron, and you can see the different parts of it. So I'm going to talk you through all the different bits. Firstly, we've got the dendrites, and the dendrites are like the little fingers that pick up the nerve impulses. I think of it with the D as the direct, it sends an impulse direct to the center of the cell, to the nucleus, which processes the information. The impulse then goes from the brain and the cell, which is processing it, down this long, thin axon, okay? And the axon is one nerve fiber, and I think again with an A, it takes the message away from the cell body. Now imagine that being down your arm or down your leg. It's going to be a very long nerve fiber. So what can actually speed up the process? Well, I tell you what, being a little bit cold here today, should have filmed this in the summer. So what have I just done? I've put on my myelin sheath. Let's have a look at the picture again. So the myelin sheath is the green coat, and this green coat, imagine this made of fat. A lovely thought there. I think Lady Gaga did it once. So a fatty coat, what's it going to do? It's going to protect you. You can run into things, you're going to bounce off it. It's going to protect your body. It's also going to make you a bit warmer, so it's really good for insulating. And finally, it speeds up nerve impulse up to 200 times. So when you've got long nerve fibers going down the arms and the legs, the myelin sheath is really important. So what do we actually mean by the word nerve and neuron? What's the difference? Well, a nerve is just a way of saying everything within a cable, let's say. Have a look at this. UK plug for my international audience, that's what it looks like. So we've got this nerve cable and it's wrapped up with the substance around the outside. Now, if I was silly enough to chop it in half, what would you see? Inside this cable, you'd see all the tiny little filaments, and those filaments are the neurons. So within one nerve, you have a selection of motor and sensory neurons. Some of them, the motor nerves, are going towards the muscle. Let's say that's a muscle. And the sensory neurons are sending impulses away to the brain. So within that one nerve, you've got a combination of sensory and motor neurons. So let's have a look at what the brain looks like inside of our skull. Skull's there for protection. There's different parts to it. You can see the different colours. So on this diagram, the blue colour is the cerebrum. Now the cerebrum is really 80% of the brain in terms of size, and it's really vital for certain functions. One of them, is memory. One of them is memory, that's it, I forgot about that one. Another one is speech. There's also intelligence, learning, vision, and knowing the difference between left and right. Left and right. So the cerebrum is really important. The bit at the back, the cerebellum, is 20% of the brain, and that is all to do with balance, coordination, proprioception. Think of a cat. What is a cat good at? Now, if you're a cat owner, you'd probably say sitting on my knee and purring and looking cute. But I would say cats are really good at balance. They can walk on a fence and stay on there with their tail. They're pretty good. They can jump off. They can land properly. We say cats have 9 lives. We don't really. But a cat has really good balance. So the cerebellum of a cat is quite big in proportion to the cerebrum. Maybe they're not the most intelligent creatures. And again, if you're a cat owner, I do apologise. You do think it's the most clever thing in the world. But unfortunately, it's not. So we're going to have a look at what different brains look like on different animals. Okay, so on the screen you can see pictures of 3 brains, 3 real-life brains. And look at the colour of them as well. It's kind of grey to red material. One of them's a human brain, one of them's a monkey's brain, and one of them's a cat brain. Now I'm sure you can work it all out because of the size difference, but let's imagine they're all the same size and look at the proportions. So what I just said previously, the cat's brain has a slightly larger cerebellum in proportion to its cerebrum because of its balance, coordination and proprioception. The monkey's brain is quite similar in proportion to the humans, but the humans is generally just bigger overall. The other vital component of the brain is the medulla oblongata. So from the midbrain coming down into this structure, which then extends down into the spinal cord. The medulla oblongata is essential for breathing, heart rate, and also reflex actions, which we're going to have a look at in a bit. The spinal cord will extend right down the back, kept within the vertebra, and it extends down to around L2, lumbar 2, before it becomes a horse's tail called the cauda equina. So this is where I tell you how clever chimpanzees actually are. And this is a true story. It was in Tokyo. Some chimpanzees were kept in a cage. It was a nice cage. It had loads of different monkey things, whatever monkeys are into, trees I presume, and logs and different playthings. So the monkeys were kept in there, but then they'd walk into this computer lab. And in the computer lab, they learned how to identify numbers in order. So for example, a number 1 would appear on screen and the monkey would have to touch the number 1. And it got to a point where they could then recognize the different numbers and tap this touchscreen. If they did it in order from 1 to 9, out popped a banana. Now monkeys, I think, do anything for bananas, as in I do anything for Mars bars. So I'm sure I could program myself to do a little bit more than I am doing at the moment. It got to a point where the monkeys became so good at this activity that they would have this 3x3 grid, and up popped all the numbers from 1 to 9 in a random order in the grid, and it came off in 0.3 seconds. So it flashed on, flashed off. The monkey would then have to touch the blank screen in the order of 1 to 9. And when they did this, they won the banana. So they invited Mr. Memory Man at the time. Mr. Memory Man can remember 52 cards in a row, but 52 packs of cards. Now, he could just reel through ace of spades, 2 of diamonds, 52 packs of cards. So the most amazing memory human there was at the time, and he did this competition with the chimpanzee. Now, do you know who won? The chimpanzee won 80% of the time. Well done, chimps. So far we've been talking about the CNS, the central nervous system, and just as a quick revision, the central nervous system is anything to do with the brain and the spinal cord. Now we're going to be talking about the PNS, the peripheral nervous system. And the word periphery means anything on the outside. So let's have a closer look. So inside the skull we've got the brain, which we now know quite a lot about, and the brain will exit from this foramen magnum, the hole in the skull, via the spinal cord. And we can see the yellow, and the yellow spinal cord sits within the spinal canal of the vertebra. But out from each side of the vertebra we can see these yellow bits. These yellow bits are the spinal nerves. Now there are 31 pairs of spinal nerves, 31 from each side, and within the brain itself we've got 12 pairs of cranial nerves. So the cranial nerves are for eyesight, for hearing, for taste, and there's 12 of those. And these will extend to different sections of the body. For example, there is a cervical plexus which goes to different organs and different muscles around the neck and into the jaw. The brachial plexus will extend down into the arm and into the hand. Then we've got the lumbar plexus and the sacral plexus, and these will extend and go all the way down the leg to the toes. So let's have a look at some receptors in the body. What do you think I'm detecting now? Ooh, okay, I'm measuring blood pressure. In fact, mine looks a little bit high today. Maybe I'm a bit nervous. What's the device called that is used to measure air pressure? It's a barometer, isn't it? So the receptors that detect blood pressure are baroreceptors. Let me take this off before my veins pop out. Hold on. Other receptors that we have in the body are chemoreceptors, and chemoreceptors will detect the amount of chemicals and the levels of chemicals within your body. For example, oxygen, carbon dioxide, or even salt levels. Another one is mechanoreceptors. Mechanoreceptors are to do with the mechanical stimuli, whether it's touch or pressure. Another one is called nociceptor, and nocere is Latin for hurt. So a nociceptor is detecting pain. Let's have a look at that. Now this shouldn't be painful. Let's come in close. What is this? I'm going to take that out. Okay, here we go. Has anyone ever done self-acupuncture before? Let's do one in my bicep. Ready? I've already got a bit of a sweat on. It's activating my sympathetic nervous system. That inch needle. Ooh, might only go in that far. So it's going to have gone in about a centimetre. So I did feel that go in. I wouldn't say it's particularly painful, and if you do have acupuncture, you know, sometimes you don't even feel the needles. But putting something like that, can you see it on the camera? Can you actually see, just out of interest, how thin an acupuncture needle is? Can you see that? So nociceptor is detecting pain. A proprioceptor detects body position. And the final one that we're going to have a look at is the thermoreceptor. I think that's quite obvious what one that is. Thermoreceptor detects hot and cold, like a thermometer. We've had a look at a few nerves of the body already, including the sciatic nerve and the femoral nerve. So let's have a look at some arm nerves. Here we have, if you can see, in green is going down to the little finger, and in anatomical position, that's over the ulna. So green is the ulnar nerve going to the little finger and the outside edge of the ring finger. The red nerve is the median nerve. The median nerve goes all the way to the inside edge of the ring finger, middle finger, index and thumb. And then the radial nerve is on the back side here. So the radial nerve comes to the back of the thumb and to the knuckles here of the first two fingers. So they're the spinal nerves from the brachial plexus that go into the arm. And if you've heard of carpal tunnel syndrome, carpal tunnel is this tight band over the top, and any inflammation underneath can press on the arteries and the nerves, causing a sensation generally in the median nerve distribution, giving tingling or maybe numbness in those fingers. So what does happen when you tap with a patella hammer on the knee and the knee kicks out? Let's look what happens behind the scenes. So this image here is quite nice. This image shows what's happening. So firstly, you've got the patella hammer hitting the patella ligament or tendon. Now the patella ligament or tendon sits between the patella and part of the tibia here, the tibial tuberosity. It's a spongy bit. Have a little feel of your own knee as you're sat watching this video. Okay, so if your leg is relaxed and you were to hit here, it's as though it's an elastic band. If you were to hit an elastic band like so, the elastic band stretches, and it's a stretch reflex. Now, because it's a reflex action, it doesn't need to go up to the brain to be processed. That takes far too long. So what happens is the stretch receptors in the tendon detect that change in length. It thinks it's been damaged or overstretched. So it sends a message through the sensory receptor or the sensory neuron right up to the closest bit of spinal cord or central nervous system, which would be here. It then sends a message through the interneuron and it comes back through a motor neuron. And remember, motor neurons are there to produce movement or for gland secretion. So the motor nerve going into the quadricep contracts the quadricep and the leg kicks out. And that whole process happens instantaneously to help shorten that tendon. So it's a protective mechanism inside the body. But also you might see specialist doctors, physiotherapists, or advanced sports massage therapists using these to have a look at the spinal nerves. So I'm going to show you a few on myself. You might get tested for nerve roots of the upper arm or the brachial plexus if you have any condition in the hand or weakness, poor sensation. So you could do a test, or someone else will do this test on you, for the bicep tendon, which is C5. So let's see if this does work. I'm going to tap my bicep tendon here. You might either see a flexion or you might see a twitch in the muscle. Let's have a look. Did you see the twitch in the bicep? If you can't see it on camera, I definitely felt it. So let's have a go at the next one. This is for brachioradialis. This is for C6 spinal nerve. So I'm going to tap the brachioradialis here. You might see a bit of a twitch, or you might see movement of the hand. Let's have a look. Whoa, that was a good one. That took me by surprise, actually. And then if there's one for the leg, we'll do the one that I talked about earlier, the patella reflex, and this is for L4 nerve. I'm quite hyperactive, hyper-reflexive, let's say here. So let's do a gentle one. It looks like I'm faking it, but it actually responds really well. On a muscle grading system, that would actually come out as brisk, whereas some people you would tap and it would be quite mild. So we can see how they work, and what that's doing is it's seeing changes or seeing how effective the spinal nerves are going to those different parts of the body. So we've covered the CNS, central nervous system, which is the brain and the spinal cord. We've had a look at the peripheral nervous system, which includes the cranial nerves and the spinal nerves coming off that, and where they go to and from, including motor and sensory neurons. And we're going to have a look now at the ANS, the autonomic nervous system, and that is also it's a division of the peripheral nervous system. So just to make things complicated, there are two divisions of this system, the ANS, and they are sympathetic nervous system and parasympathetic nervous system. I like to think of these two systems as opposing, and I think it's quite nice to think of buzzwords for these systems. So for sympathetic nervous system, we're going to use the buzzword of stress. We're going to think of a stressful situation. And for the parasympathetic nervous system, we're going to think of the word paradise and imagine ourselves lying on the beach. So it's late at night, I'm walking down the road on my own, it's dark, I hear something behind me, I go to have a look, get my phone out, and someone comes to grab, maybe they push me, however they do it, they get the phone out of my hand, and now I'm in a position of panic. I can feel the adrenaline going into my body, I've really got two decisions. One is, well, I am a martial artist, attack, or more sensibly, what else should I do? I should run away as quickly as possible. Okay, I need to preserve life. So it's called fight or flight. So if I was fighting or flying or getting away from that situation, now imagine how my body's feeling. Okay, so I'm starting to feel a bit hot. My heart rate has gone up a bit. I've got some palpitations going on. My breathing's got quicker. My mouth feels really dry. My pupils have dilated. They're picking in everything around that situation. So I'm deciding what to do. I think I've got out of there as quickly as possible. I've lost my phone, but I'm alive. That's the first one. That's our stressful situation. Now, I'm doing an extreme for that one, but let's think about doing an exam. You're nervous, you go into the exam, your hands are sweaty, your breath's a bit quicker. That nervous system exam you've got coming up, okay, watch this video again and again. Ah, paradise. Sunbathing, listening to the water, listening to the waves, smell of a beach barbecue. Waiter, waiter. Glass of Prosecco. Now imagine, how is my body feeling now? Actually a bit excited about that, but apart from that, how's my body feeling? So my breathing has slowed down. My heart rate is definitely reduced, and being lying, my blood pressure's dropped a bit. I can smell that beach barbecue. My taste buds have been activated. I actually think I need to go to the toilet. When we're in this state of the parasympathetic nervous system is activated, you're more likely to do daily functions. Another way of saying it is rest or digest. So we're resting on main body systems, but then the digestive systems are increasing. So the salivary glands and activation in the stomach, the gastric juices preparing to eat. So have a think of those two buzzwords, paradise and stress. That was the nervous system in a nutshell, and I hope it answered the 3 questions at the start. If you like the video, I'm going to be releasing more on anatomy as well as massage and rehab advice. So please like and subscribe and watch the next one.